Welcome back to another session on DSA. So in this particular session, we will solve another question on matrix and we are going to pick this particular question from the LeetCode. So first let me take you to the LeetCode and then let's see what the question is. So the problem number is 240 in LeetCode. Search a 2D matrix 2 is the problem name. So it's a median problem. Now let's try to read this particular problem. It says write an efficient algorithm that searches for a target value in a m into n integer matrix. So basically they would have given a m into n matrix. So it's not a square matrix for sure. So it can be 5 into 2 or 4 into 3 or 2 into 5, these kind of matrix. So integer matrix, the matrix has following properties. So they have given some properties of the matrix as well. So what is it? Let's read. Integer in each row are sorted in ascending order from left to right. So they are saying each row is sorted. Next, integer in each column is sorted in ascending order from top to bottom. So they are saying each columns are also sorted. So let's go and see one particular example in this case. So if I take this particular example, it is 5 cross 5 matrix. But it's not necessary that all the examples will be n into n or square matrix. So in this particular case, they are given as a square matrix. Let's see the properties that they are mentioned. Now, if I observe this first row, 1, 4, 7, 11, 15. The numbers are sorted. All the integer values over here is sorted in ascending order. If I see the second row, 2, 5, 8, 12, 19. These elements are also sorted in the ascending order. Same way, if I see this row and this row, all the elements are sorted. And same way, if I come to the columns as well, 1, 2, 3, 10, 18. Or 4, 5, 6, 13, 21. 7, 8, 9, 14, 23. Every column is actually sorted. Now all that you need to do is write an efficient code to find whether the target value is there or not. So in this particular example, they have given the input in this format and the target value over here is 5. Since 5 exists in this particular input, you should return true. So the output will be true. If I slightly scroll up, you can see it over here. So it is true. But in case if the element does not exist, you need to return false. So let's see the second example. So if I go to the second example, you can see they have given a certain matrix and the target value over here is 20. And if you observe in this particular matrix, there is no 20. So you need to return false in this particular case. So I hope the question is completely understood by you. I want you to go and try and write an efficient solution for this particular algorithm. I hope you tried solving this problem by yourself and I hope the code that you have written is an efficient code. In case if you are not able to write an efficient code or in case if you could never write a code, do not worry. I will explain you the logic behind this particular program. So basically they have given you a matrix and they have given you a target element. So all that has to be done is just find whether this particular target element exists in this matrix or not. In case if you are not able to write even a brute force method, that's very bad news. In case if you are, that's great. First what I would like to do is I will explain you the brute force way of doing it and later on I will explain the efficient method. So brute force way of doing it is very simple. All that I have to do is check whether this element exists in this particular matrix. But how would I check is I will start from this particular index or from the first element. And I will keep on traversing all the elements and I will keep on checking whether that particular element I am present at, is that the element that I am checking for. Basically, I will start from this particular element. I will check whether this element is the target element. No. So I need to check the next element. I will check whether this element is the target element. No. I need to check the next element. I will check whether this element is the target element. No, I need to check the next element. Since this is not the target element, move to the next. Since this is not the target element, move to the next. And keep on doing the same thing till the last element. In case if you find the target element, in this case you will find it over here, directly return true. In case if you do not find after reaching over here, then return false. So I hope this is nothing but linear search and whatever linear search that you have applied for one dimension array, the exact same thing can be applied to this particular matrix as well. So this is nothing but a 2-dimension array. I am not going to write code for this particular approach because I hope you already know how to traverse an array and write one simple if condition. But what I am going to explain you is an efficient approach. But before explaining the efficient approach, let's see what is the time complexity of the brute force approach. So in case of brute force approach, what you did is you traversed all the elements. So basically, how many ever elements are there, so many number of times the loop has executed. So how many elements are there over there? There we have 4 rows and 5 columns. So it's nothing but 4 into 5. So basically I can say as n into m. So the number of rows into number of columns is your time complexity. So what is the time complexity of this particular algorithm? It's nothing but big O of m into n. Now let's see how can we approach for an efficient solution. So one property that we know about this particular matrix is all the rows are actually sorted in the ascending order. Not just that, all the columns are also sorted in the ascending order. Now what I would do is, I will not start checking the element from here, rather I will start checking the element from here. So this particular logic works somewhat like a binary search algorithm, but not exactly like a binary search. So what I would do is, I will start from this particular index. So this I value will be 0 and the value of j will be the last column number. What I would do is, I will check whether the element present in this particular index, that is I and j, is that the element that I am searching for? Means, is that the target element? If it is the target element, I will return true. Or else what I need to do is, I need to check whether the element I am searching for, this is the element that I am searching for, is this smaller than this particular element or greater than this element? Why I am doing this is very simple, because in case if the element that I am searching for, that is 5, if it is smaller than this particular element, I know definitely exists on this side and not on this side, because this column is in ascending order and all the elements towards below this are actually greater than this particular element. So you know for sure that the element does not exist in this particular column. This is the basic idea behind this algorithm. So what would I do is, in case if the target element is actually smaller than, if the target element is smaller than this particular element, I know the element exists on this side. So what I would do is, I will decrease the value of j, basically I mean to say I would decrement the value of j by 1, so that I don't have to check all of these elements. Now the value of I is still 0, value of j is 3. Now what I would do, again repeat the operation. I will check, is the element present in the ith and jth index, so AR of ij, that is nothing but 11, is 11 equal to 5? Is it equal to 5? No. Now what I need to check is, I need to check whether 5 is smaller than 11 or greater than 11. In case if 5 is smaller than 11, what I can understand is, definitely the element does not exist over here, because all of these numbers are actually greater than 11. So definitely 5 is smaller than 11, so 5 would exist on this side, so I need to decrease the value of j. So if you had observed over here, whenever the target value is less than AR of ij, I need to reduce the value of j. Next, what I will do is, now this is the element, I is 0, j is 2, so AR of ij is 7, so I will check whether target value is equal to the AR of ij. Is it equal? No. If it is not equal, I will check whether this target element is greater than this element or smaller than this element. You know very well, this particular element is actually greater than the target element. So I can say target value is less than this particular element, AR of ij. Since it is lesser, you know very well, the element would not exist in this particular column, because all the elements below this are greater than 7. So what I can conclude is, the value of the target element will exist on this side, so I will reduce the value of j by 1. Now the value of j would have actually become 1 and the value of I is 0. So now the element that I have picked is nothing but 4. Now what I would do is very simple. I will again check whether the target element is that equal to AR of ij. Is it equal to AR of ij? No. So in case if it was equal to AR of ij, what is that I had to write is, I had to just return true. So I will just write that condition as of now. If AR of ij is equal to the target. If AR of ij is equal to target, I need to return true. In this case, it's not. Now, if it's not the case, I need to write else, and there are two more possibilities. Either this value is smaller than the target element, or this value is greater than the target element. So what is the condition I will be writing is, I will check, is this particular value, that is the target value, smaller than this element? So in all of these cases it was smaller. So whenever it was smaller, what I had to do, I used to reduce the value of j by 1. So I will write that condition as well. I will say else if the target value is less than AR of ij. So in all of these cases, AR of ij was greater, so target value was lesser than AR of ij. I reduced the value of j, so I'll say j minus 1. Else, the only possibility left out is target element is greater than AR of ij. So if I come and check over here, definitely target element is not smaller than this, so it's definitely greater. If it is greater, you know very well it does not exist on this side because all the elements towards this side is smaller. So definitely it exists below this. So now I don't have to reduce the value of j, rather I need to come one row below. How can I come one row below? Just reduce the value of I by 1. So that's all I have to do. So what I need to do is, I need to write else and increase the value of I by 1. Now if I come over here, now the value of I is 1, the value of j is 1. I will check, is the target element equal to AR of ij? Is it equal? Yes, it's equal. Return true. That's all. So this is the algorithm that I need to write. Now the thing over here is, this particular thing I actually kept on checking again and again and again. Now don't you think I need to write this particular code inside a loop? Yes, I need to write this code inside a loop, but what are the conditions for the loop? Very simple. Two things is what I need to take care of. Now basically what happens is, in case if the element does not exist, what happens? Either the value of j will start from here and come all the way till 0 and cross this 0. That's one possibility if the element does not exist. One more possibility if the element does not exist is, the value of I will start from 0 and come all the way till here and cross this value. So that's another possibility. So to just clarify this thing to you, what I would like to do is, I will take another example where the element does not exist. So that example is also taken from LeetCode itself. So I am taking up this particular example. So the elements remain same, but the target element is 20. Now let's start tracing the code that I had already written. So what was the code that I had written? Very simple. I will start from here. First thing that I need to take care is, the value of I should start from 0 and the value of j should start from length minus 1. So if you observe over here, I will not say AR.length or length of AR, because if I say length of AR, it will give me 4 because there are 4 rows. But what is the length I need? I need it as this 4. So basically it is 5. So there are 5 elements and I need the last index. How can I get this? Very simple. If I say AR, it means the complete matrix. But if I say AR of 0, it means this particular array. So if I get the length of this particular array, then you know that I can get this index by saying minus 1. So j value starts from AR of 0 minus 1. So length of AR of 0 minus 1. So that's how I can start the value of I and the value of j. Now all that I need to do is just trace that particular algorithm. So what did that particular algorithm do? It checked if the value of AR of ij equal to the target element. Is it equal to the target element? No, it's not equal. Then there are two possibilities. Either the target value is lesser than the AR of ij or it is greater than AR of ij. So if you observe in this case, is this value lesser than AR of ij? No, it's not lesser. So if it's not lesser, I don't have to reduce the value of j, rather I need to increase the value of I because I have to come down. So the value of I gets increased. Now the value of I would have become 1. Now I need to check. Now the element that I have selected is 19. So I will check, is the target element equal to 19? Is it equal? No. Since it's not equal, two more possibilities left out. Is the target element lesser than 19 or the target element is greater than 19? So 20 is definitely not lesser than 19. So 20 is greater than 19. So the element exists below this. So what I need to do, increase the value of I from 1 to 2. That's all I have to do. Now the element that I have picked is 22. I value is 2, j value is 4. Now I will check, is the target element that I am searching for, that is what, 20. Is that equal to 22? No, condition fails. If condition fails, two more possibilities, either 20 is greater than 22 or lesser than 22. In this case, 20 is definitely not lesser than 22. It is lesser than 22. So since 20 is lesser than 22, you know the element does not exist below this, rather the element exists towards left side of this. So what is that I need to do? I just have to reduce the value of j now. So the value of j reduces. Now the value of I is 2, the value of j is 3. Now what is that I need to do is, I have to again check the same thing. I will check if the value of AR of ij, that's nothing but 16, is 16 equal to 20? No, it's not equal. Now I'll check, is 20 less than 16? No, 20 is not less than 16. It is greater than 16. If it is greater than 16, you know very well the element does not exist on the left side of 16, rather it would exist below 16. So what I have to do is just increase the value of I. So I will increase the value of I. Next, what I have to do, I'll check whether this is the element that I picked. I value is 3, j value is 3. So the element is 17. So I'll check, is 17 equal to 20? Is 17 equal to 20? No. So what I have to do, I need to check, is 20 smaller than 17? So target is less than AR of ij. No, it's not. So it is definitely greater. If it is greater, it's definitely not on the left side. The element is not on the left side, but it's below this. So what I will do is, I will go below this. So the value of I will actually cross 3. So what happens? The value of I becomes 4. Now once the value of I reaches over here, you definitely know there is no element over here. This is nothing but out of bounds exception. So once you reach this particular situation, you can clearly say that the element does not exist. So when are you actually stopping the iteration? When the value of I is actually crossing this value. So that is when you are actually stopping the iteration. But this is not the only possibility. There is one more possibility. Maybe the value of j will also cross this. While it keeps on reducing, it might reach -1. So there are two possibilities. So I need to check whether both the possibilities are passing or not. So what is the condition that I have to write is, every time the value of I should be less than this value or equal to this value. So that's the first condition. Value of I should be less than length of AR. So length of AR will give me 4 in this particular case. So is the value of I less than 4 is what I need to check. So less than 4 means 0, 1, 2, 3. The condition, if it is satisfied, I need to iterate this particular operation. This is not the only case, is what I told. One more situation is whenever the value of j is actually greater than or equal to 0, because if you observe 0, 1, 2, 3, 4, it has to check. But if it is not, it should stop checking. So what I need to say is the value of j greater than or equal to 0? So it will check for 0, 1, 2, 3, 4 and anything beyond. So if both the conditions are satisfied, only then I need to iterate this particular operation. If it doesn't, I need to stop. So since both the condition has to be true, I need to write it as AND operation in between. In case if I do not return true and I come out of the loop, you know very well the element does not exist. So I need to return false. So this is an efficient algorithm. And if you observe in this particular algorithm, or if you ask me what is the time complexity of this algorithm, you know very well, in this particular situation, this was the worst case, that the element did not exist. What exactly did we do? We actually traversed few elements. How many elements exactly did we traverse? We traversed 15, then came to 19, then came to 22, then 16, then 17. So basically 1, 2, 3, 4, 5. 5 elements is what we checked. So in worst case, how many elements will we check is something like this is what we might check. 15, 19, 20, 22, 24, 17, 14, 13, 10. Maybe we will come one full end, from one end to another end. So in this case, the time complexity is nothing but big O of m plus n. So if you can clearly see, there is a huge difference between big O of m into n and m plus n. And definitely m plus n is lesser than big O of m into n. So I hope you understood this particular algorithm. Now let's go write some code and check whether this algorithm works or doesn't work. Now let's write some code for the algorithm that we have already discussed. So basically we do have one matrix and one target element. Now all that we need to do is we just have to implement the code that we have discussed. So basically, if you had observed what exactly we did this, we started traversing from the last element of the first row. So I need two variables for indexing. So one is I and the other one is j. So I will take care of row. So before I write the code, I will just drag this so that I have sufficient space over there. Yeah. So one variable is of I. So it is of integer type. So I'll say int I is equal to 0. Now the other variable is j. So the value of j should be pointing to the last element in the first row. So the last element in the first row, how do I get it? I need to get that index. So how do I get the first row? Let's see. It's very simple. AR of j is equal to AR of we have a matrix over here, so I will rename this matrix to AR, and over here also I will write it as AR. Just for easy coding, I am doing these changes. So AR of 0, AR of 0 is nothing but your first row. I want the length of this, so I will say dot length. Now this no parenthesis, because it's an array. So this will actually give me the length of the first row, but I don't want the length, rather I want the last index. So how do I get it? I just have to put -1. Semicolon, next line. Next, after this, all that I need to do is I need to start traversing. So I had written two conditions. So let me write those conditions. So first I'll say while. Now the condition is the value of I should be within the range. So I need to ensure that once it's incrementing, it doesn't cross. So what I will do is I'll say I is less than AR dot length. Next, one more condition I need to write. Since the value of j keeps on decreasing, I need to ensure that it doesn't crosses 0. So I need to ensure the value of j is always greater than or equal to 0. So I am saying greater than or equal to 0. Next, since both the conditions has to be true, I will put AND operator in between. Next, I will put brackets. Within this, there are three possibilities. Now the element that I have might be the element that I am looking for. That's nothing but the target element. It might be equal, or else it can be greater or it can be lesser. So first let's see, in case if the element I am looking for is this particular element, that is nothing but AR of ij. So I will write one if condition. If AR of ij is equal to target. Great. Next, inside that, if this condition is true, it means I have found the element. So if I found the element, I need to say I need to return a boolean value, that's nothing but true. So I'll say return true. Return true. Great. Next, if this is not the possibility, there are two more possibilities. The target element might be smaller than AR of ij, or the target element might be greater than AR of ij. So first I'll take care of smaller. So I'll say if once again else if, because only if this fails I need to check this. So I'll say else if, over here I'll check, is the target element less than AR of ij. Great. Now in case if it is less than AR of ij, in that case I clearly know that the target element is actually towards the left side. So what I need to do in this case is I need to reduce the value of j by 1. So I'll say j minus 1. Now, if this is not the case, nor this is the case, there is only one more possibility left out. That's nothing but this target element is greater than AR of ij. And in case if target element is greater than AR of ij, I know it's somewhere down. So what I need to do is I just have to increase the value of I. So what I will do is I will say else, and I will increase the value of I. That's all. So let me run the code and check if this code is actually running. But one more case I have not taken care of. In case if I find the element, it will return 2. If I don't find the element, it will never come inside this loop. This loop will exit at one point, and once I come out of this loop, I need to return false because I would have not found it. So I will return false over here. Return false. Yes, great. Now I will run the code. So the sample input has been accepted. Now let's go and submit and check if it is actually accepting all the test cases or not. So in case if I submit it, so it's actually judging. So it says runtime 4 seconds, faster than 100% of the Java. So this is one of the best solution in the LeetCode for this particular problem. So they are saying this is faster than all the other Java submissions that has already been made. That's really great. So I hope you understood this particular program properly. I would actually suggest you to go and pick problems from LeetCode, as LeetCode has many problems which are asked in FANG companies or any other product based companies. So find problems on matrix as of now and try solving those problems. In case if you face any difficulty to solve those problems, make sure that you put those doubts in the Slack so that our mentors are always there to help you out.